Yeah, for a problem like this one, actually the one on the right here, I'm going to show in a different, I'm going to use a different method to solve that. And if you guys like it, use it. If you don't, use the old-fashioned method, okay? But here on the left, we're going to solve this. I'll use red again so that when we graph it, it's still kind of consistent with what we did last time. Yeah, we're going to zero out the 3 first, right? So I got negative 2x is greater than 6 now. And now I'll divide both sides by negative 2. And dividing by the negative, it's going to flip that inequality to be negative 3 right there. So that finishes off that one. And almost for the sake of time, the second one here, and yeah, I'll do this one in green. Just for the sake of time, I'm going to divide both sides by 4 first, cancel out the 4 to distribute, which makes this x plus 1 is less than or equal to 3. If you guys like that trick, use it. If not, now I can only do that because there was just this one term, the 4 times the x plus 1. That zeroes out the 1 now, and x is now less than or equal to 2. So we have these two inequalities that we're going to use to graph, and it is an and statement, right? So I need values that are true for one and the other as well. So on the graph, we got x is less than negative 3, so I'll put 0 here, 1 to negative 3, and then 2 is going to be over here. It's an open circle at negative 3. It's not eating x, so it goes to the left. The 2, it's a closed circle at 2, but it's not eating the x either, so this one also goes to the left. Now it says it's an and statement for this one. So if we evaluate this number line right here, in fact I'll redraw it right here, right? Got 0, negative 3 there, and there's 2. Well, it's true for one and the other, right? Well, that's true in this range where the two lines intersect, right? The green and the red. And we can see that they stop intersecting at negative 3 here, right? So if I bring this negative 3 down, negative 3 would make the green inequality true. Put that on the screen there. It makes the green inequality true, but not the red one, which means it has to be an open circle right here. And then everything to the left of it is where the two lines intersect, which means that all of these values to the left of negative 3 would make the red and the green inequality true. So even though we have this number line that we started with up here, the real number line we would want to put on the graph for the homework is this one right here. And of course that's just the graph. So let's finish this off with the interval. So the interval, this one goes as far to the left as negative infinity. It stops at negative 3. It's not included because it's an open circle. So yeah, we got to use a parentheses right there.